All right, so previously we talked about spontaneity with in terms of E cell. And so if you think about spontaneity, you should be thinking about delta G, which in return is related to K. And so it is true all of these things are interrelated. Slash, kind of the same thing, just in different languages where some uses are more appropriate than others. So let's think about what a spontaneous at equilibrium and non-spontaneous reaction look like in terms of these three values. So we'll have spontaneous over here, at equilibrium over here, and then non-spontaneous here. And remember, non-spontaneous means basically spontaneous in the opposite direction. So if we think about delta G for a spontaneous reaction, remember that has to be a negative number. If we think about E cell in a spontaneous reaction, remember this is a positive number. And then if we're talking about in standard states, if we're talking about K has to be greater than 1 for a spontaneous reaction, or that Q is less than K. And so Q is going to grow and become K. At equilibrium, you're thinking delta G is equal to 0. E cell is also equal to 0. K is equal to 1 at standard states. And if you're not at standard states, you're thinking about Q equaling K, right? Once Q equals K, your reaction stops and you're at equilibrium. And then finally, non-spontaneous, if you're talking about delta G, you're talking about it being a positive number in terms of E cell. Non-spontaneous, if positive is spontaneous, then negative will be non-spontaneous. And then in terms of K at standard states, you're talking about a K less than 1, or non-standard states, you're talking about a Q greater than K. And so you're going to go, Q needs to shrink, so it's going to go towards more reactants. It's like I said, they're all interrelated, all kind of the same thing. So let's take a look at that. If we think about the E cell, it's measured in voltage. And remember, voltage is joules per coulomb, where joules is a measure of energy. And this is energy that can be used to do some work, right? So we'll call this kind of energy for work. W. And then C is a unit of charge. It's a coulomb, and Q is also a symbol for unit of charge. So Q is heat and charge, a little bit confusing, but whatever. So we can actually reorganize this reaction or this equation, right? Substitute in work for these joules, and we get our work max is equal to negative Q of the E cell. So you're thinking about where the heck is this negative coming from? We're just talking, it's kind of semantics, but we're talking about work done by the system. Right, we just changed in J or joules for work done, and then we made it negative because work is being done by the system, and then we switched in Q for coulombs to make it just into generic charge. And so you can actually go further for this. You can see the book for the derivation. Right, this isn't a calculus or a math class, so we won't really do derivatives. But think about it. Work max, what does that also mean? Well, that's delta G. And so delta G ends up being NF E cell, where N is the number of moles of electrons. F is Faraday's constant. And it's basically how much charge does a mole of electrons have? And so it's 96,485 coulombs is 1 mole of electrons. And then think about E cell that has units of joules per coulomb. So if you're thinking about these units, the moles of electrons here will cancel out with these moles of electrons. And then this coulomb will cancel out with this coulomb. And so then you'll just be left with joules, which is the unit for delta G. So it makes sense. And so you could be asked to do kind of plug and chug type problems. Pay attention to your units. Make sure if it asks for delta G in kilojoules, you make it into delta G or into kilojoules and whatnot. And so let's take a look at another case here. Remember, we said before delta G at standard states is equal to negative RT ln K. And remember, delta G, we just said, is equal to negative NF E cell. And so thus, negative NF E cell must equal negative RT over ln K. And so you can take this a step further. Basically, just put RT and NF together. You can check out your book. And you get this equation that relates K and E cell. So E cell equals 0.0592 volts over N times the log of K, where N is your moles of electrons and K is your equilibrium constant. Or sometimes you'll see it written out slightly differently, but it's the same equation, and that it's E cell equals RT over NF ln K. And so they're the same equation, just written slightly differently. So you can see all of these are interrelated, and I could ask you kind of plug and chug type of questions. And I like this diagram from your book right here. So you can see you can go from delta G to K to E cell or any kind of way in between. And then there are the equations for all of them, right? And then here's kind of what we stated previously with the relationships between K, delta G, and E cell, and kind of gives you a definition of each. So go ahead, check those out, make sure you understand them.